Hi, and welcome to our next Level 2 Networks video. In this video, we're going to talk about this word, traversability. We've so far talked about networks consisting of edges and nodes. Right, now in this video, we're going to talk about this word, traversable. A network or a graph is traversable if you can start at a vertex and traverse or travel the entire network without retracing any edges. We looked at this idea in our last video with Euler circuits and Euler paths. Like for this example, this network here, we have four nodes, A, B, C, and D. And we talked about degree. Degree is how many edges come into the node. So A has a degree of 2, B has a degree of 2, C has a degree of 3, and D has a degree of 1. All right, well, we're going to classify each node as either an odd or an even node, depending on whether the degree is an odd number or an even number. So A and B are both even nodes, and C and D are both odd nodes. All right, well, here's the information you need to understand for this video, and you may want to pause it and jot this down to help you remember it. You can only traverse a network if none of its nodes are odd, i.e. all nodes are even. Now, this is called an Euler circuit, and you can start at any node. You can also traverse a network if exactly two of its nodes are odd. This is called an Euler path. One of the odd nodes will be where you start, and one of the other odd node will be where you finish. And the network is not traversable if it has more than two odd nodes. So if it's got no odd nodes, it's traversable. If it's got exactly two odd nodes, it's traversable. But if it's got more than two odd nodes, it's not traversable. Now, mathematics has shown that a network has to have, if it's got odd nodes, it must have an even number of odd nodes. So it's either no odd nodes, two odd nodes, or four odd nodes, and so on. And anything greater than two odd nodes is not a traversable network. All right, let's go through some examples. Here's the first example where there's no odd nodes. So all nodes have a degree of 2. They're all even nodes, and therefore you can start at any even node and it is traversable. You can start and finish at the same node. So let's go through this once more from node A to B to C to D to E and back to the start point. It's an Euler circuit because we start and finish at the same point. All right, what about example 2? This network has exactly two odd nodes. We've used this network before in our videos. There are four nodes. Two of them are even and two of them are odd, so exactly two odd nodes. So we must start and finish at the odd nodes. So if I started at E and moved to C, up to B, up to A, and back to C, I've started at the odd node of D and I've finished at the odd node of C. I can't start at an even node and traverse that network. All right, here's example 3. In this example, we have more than two odd nodes. We have four nodes and they all have a degree of 3. So they're all odd nodes. So we've got four odd nodes. And in this example, it's not traversable because there's more than two odd nodes. And as a quick example, let's see if I can demonstrate how it's not traversable. I'm starting from A to node C, up to node B, across to node A, down to node D, and back to node C. But notice I haven't traversed along the edge between nodes B and D, and I can't go back along the edges. However, let's look at an old classic. Let's take the example we just looked at and add the roof. I bet you may have done this when you were a kid. Try and draw this house without lifting your pen off the page. It's got 5 nodes, 2 of them are odd, and 3 of them are even. That's why this is traversable. So we must start at an odd node and finish at the other odd node. In the example I'm going to use, I'm starting at node D to C, up to B, up to E, down to node A, across to node B, back to node D, up to A, and finishing at the other odd node, which is where we finish. Oops, sorry about that. Right, well, that's us for the video. So thanks very much for watching.